final stage of levelling for the foundations was to add the quarry dust. Once the quarry dust was added, it's then levelled by hand. You can see it being done here using a board and two pipes, one either side, just to give us that correct level. Once levelled, every effort is made not to walk on it, and the blocks are then laid. Every penetration through the slab is individually formed. Each block is laid such that there are no thermal breaks. This means there are no direct paths all the way through, from top to bottom. Each piece interlocks with the one next to it, and the connections are nice and tight. This helps keep the blocks in place. It also helps prevent any air, particularly cold air, from moving through the slab, again helping with the thermal bridging and the overall thermal qualities of the slab. All of the slabs of the foundation are a uniform size, so in order to make things fit, we have to cut some of them down. Each of the perimeter pieces is 500mm high, and each slab is 250mm. Overall, this gives us a U value of 0.1. With the foundations prepared, the system is surprisingly quick to lay. One of the advantages of the raft system is that it can accommodate different shapes. In our case, we have a curved wall, and the foundations are able to mirror that curve exactly. course, curves and straight edges don't really work, so there was a little bit of trial and error to make sure that everything fitted. Now the raft is finished, it's time to bring the surfaces through. With all the penetrations through the slab suitably foamed and therefore sealed, the next step is to lay a radon barrier and on top of that some steel reinforcement. The radon barrier is just laid on top of the slab, and then afterwards it gets weighed down with the steel reinforcement and ultimately with the concrete. The steel reinforcement is laid with a couple of layers and some uprights in between to keep them apart.